Everyone, welcome to the explanation. So in today's video I'll be starting the topic 7.1 from our syllabus, that is NEC license exam preparation. Okay, so this is a topic for NEC license exam, and today I'll be starting the topic 7.1 and I'll try to cover 40 questions from here. Okay, so without any delay, let's start. So first question is, which of the notes for all these topics has been uploaded in my website. You can go and visit there. So first question is, which of the following is a primitive data type in most programming languages? Okay, so talking about before giving the solution of this, let's talk about what is primitive and what is non-primitive data type. Okay, so if you go to data structure, the very first chapter we will have to study this topic, data structure, that is primitive and non-primitive data. Okay, so primitive data structure, I'll write this with P, and non-primitive data structure. Okay, so let me choose another color pen, black pen. Okay, so primitive and non-primitive. Okay, so primitive means they are the fundamental data type, fundamental data structure, fundamental data type which we use in our programming language. So there are some primitive data types. So they are integer, real or float we can say. Okay, character and boolean. Okay, and one more primitive data type is null. Okay, fine. And talking about the non-primitive data type, it is again divided into linear and non-linear. Okay, so in non-linear we have tree and graph. In linear we have array, linked list, stack and queue. Okay, sorry for this, I don't have any space here. So these are the primitive and non-primitive. I'm just doing the revision of this topic. Okay, so let's go to the first question. Which of the following is a primitive data type? Array. What is array? Array is a non-primitive data type. Integer, yes. Linked list, no, it is also non-primitive. Tree is also non-primitive, so integer is the correct answer. See, if you know this table, you can answer all the topics related to this, and one question is asked from this topic. Okay, these are very basic, this comes under very basic questions. Okay, which data structure is a non-linear in nature? See, I have already done this diagram. So in non-linear we have got tree and graph. Queue, no, it is a linear. Stack, what is linear, what is non-linear? In linear, the data is inserted or deleted in a linear form. They are in linear format. But in non-linear, the data is stored like this. Okay, not in a straight or linear way, but in this hierarchical way, or child, or like this in graph way. Okay, so queue, it is a non-linear, no. Stack, it is also linear. Linked, it is also linear. So tree is the correct answer. Let's go to next question. Sorry for this. Which of the following is a non-primitive data type? Okay, non-primitive. So what were primitive data type? Float was a primitive data type. Yes, character was a primitive data type. Boolean was a primitive data type. So array is the correct answer. Okay, so please remember this diagram. Okay, next one is, yes, I think we did this. Next question is, okay, which data structure follows the last in first out principle? Okay, so there are basically two principles, last in LIFO principle and first in first out principle. Okay, so in case of a stack, if you see, okay, in case of stack, if you see, suppose if you want to store number 1 2 3 4 5. Okay, so first of all is stored 1, then 2, then 3, then 4, then 5. See, this is the stack. So last number that you have put, so we have to pop the same number. It means LIFO principle, last in first out principle. Okay, so which data structure follows last in first out principle? So stack is the correct answer. Okay, now what about FIFO, first in first out? So in case of queue, if one person will enter like this, so he or she will be the person that goes out. So queue follows this FIFO principle. Okay, sorry, so this is the answer. Let's go to next question. last in first out, yes. Which of the following is a primitive data type? Again primitive, so set is also not a primitive data type, graph is not a primitive data type, hash table is not a primitive data type, so boolean is the correct answer. Which data structure follows FIFO? As I discussed earlier, so Q is the data type that follows the FIFO principle. Next question. Which of the following is a non-linear data type? Okay, non-linear means there are two non-linear data structure, that is tree and graph. So here graph is the correct answer. Let's go to next question. Which data structure can be implemented using both array and linked list? Okay, so if you have studied or if you have gone through the data structure playlist, we know that in case of stack, it can be implemented using both linked list and array. Okay, so stack is the correct answer. Let's go to next question. Which of the following is a primitive data type? Okay, primitive data type. So primitive data type here, structure no, queue no, graph no, so double, it's also very similar to floating point number, so double is a primitive data type. Let's go to next question. Which data structure allows element to be accessed randomly using an index? Okay, random access. So which data structure will provide random access? Stack no, because stack, if you want to go to this element, you have to pop all this element. Okay, queue also no. Okay, linked list no, you have to visit list by list. So array is the correct answer. Array is a data structure which allows random access to any element. Okay, fine. So these were the primitive data type portion. Now let's go to next portion, that is abstract data type. Okay, so what is abstract data type? If you go to the definition of abstract data type, it is a mathematical model, okay, which represents any data structure behavior. So just remember two terms here. It deals with the data structure behavior. For example, if stack is there, so stack is a type of ADT or abstract data type, because the behavior of this data structure, it is defined by two operations, push and pop. Okay, so it is a abstract data type. Okay, so which of the following best describes the abstract data type? A concrete implementation of data structure, a mathematical model representing data structure behavior. Okay, so as I told you, if this word comes, this is the answer. Okay, so B is the answer for this. Next one is which of the following is an example of non-linear data structure? Non-linear, only two non-linear data structures are there, graph and tree. So tree is the correct answer. Next, which data structure? I think this is we are repeating the question. Which LIFO principle? Stack. Next one, what is the time complexity for accessing an element in an array? Okay, so remember, an array, it always provides a constant time access, because in array, if you want to, this is the element, okay, so 0 1 2 3 4, so if you want to access this element, and suppose the name of the array is A, so if you want to access this element, you can directly access this using the index A of 3. Hence it always provides a constant time access. Okay, so can you tell me which is the constant? Yes, O of 1 is a constant time access. Let's go to next question. Which of the following operation is not typically supported by stack data structure? Okay, push, yes. Pop, yes. So in stack, what is push? Push means to insert element. What is pop? Pop means to pop the element or take out the element. Peep means to see a particular element. Okay, so here in queue operation is not for stack, in queue operation is for queue. Okay, so this is the answer. Okay, let's go to next question. Which data structure is suitable for implementing a FIFO? I already told this question, so Q is the correct answer. Let's go to next question. Which of the following is an example of dynamic data structure? Okay, so dynamic data structure. So linked list, it is a data structure that is used to dynamically allocate the memory. Okay, so why we replaced or why we learn linked list over this array? Due to this dynamic data structure nature. Okay, so in linked list we allocate the memory, like if you want to add a 2 byte of number, so we will allocate 2 byte only. Now if you want to allocate 4 byte of number, we will allocate 4 byte only. Okay, so in this we allocate the memory dynamically in the case of linked list. Next one, which data structure, okay, which data structure is commonly used for implementing recursion? So if you have seen my C programming playlist, we have already discussed this. So for implementing recursion, we always use stack data structure. Okay, next one, which data structure is suitable for implementing a priority queue? Okay, priority queue. So if you have already covered your syllabus of data structure, in that you have seen this. For priority queues, like priority queues means which number will come first, which will come last. So for implementing this priority queue, stack no, it is not used. Queue linked list, no, we will not use this. We are going to use heap data structure. Okay, so using heap data structure, heap allows efficient insertion and deletion of element based on the priority. Yes, so heap is the correct answer. Let's go to next question. Which of the following is not a fundamental operation on tree data structure? So we can see this: insert, delete, sort, all these are the operations for data structure, tree data structure, but pop is not a fundamental operation, so pop is the correct answer. Okay, now let's go to next portion of this data structure, which is time and space analysis. Okay, so remember, I am covering all the topics according to your syllabus of license exam. You can see the syllabus. I am covering the questions topic by topic. Okay, what does big O notation represent in the context of time complexity? Okay, so if you have studied the asymptotic notation for data structure, so big O notation, it is always used to represent the upper bound. Okay, upper bound or maximum time complexity of an algorithm, typically for the worst case scenario. Okay, so maximum time is, for example, if you are using an algorithm, suppose if you are using a bubble sort to sort the number, so what is the maximum time it is going to take to sort the numbers? This is called your upper bound, or and this upper bound is given by this big O notation. Okay, so what does big O notation represent in the context of time complexity? So see, so upper bound means maximum time. Now if an algorithm takes a maximum time or more time, it means that it is going to give the represent the worst case scenario of that algorithm. And if it is going to take minimum time or less time, it is going to give the best case scenario of that algorithm. So upper bound means it is going to give the worst case scenario of the algorithm. So this is the correct answer. Next, which notation provides a tight bound for both upper bound and lower bound? Okay, so remember, big O notation, it is used for upper bound. Okay, now next one is theta notation. It is used for tight bound, we can say tight bound for both upper and lower time, and this is used for the lower bound. Okay, so theta is the correct answer. If an algorithm has a time complexity of O of n, what does it mean? Okay, so O of 1 we already studied, it gives the constant. Yes, constant time. Now what is O of n? O of n, it gives the linear time. Okay, O of n square, it gives the quadratic time. Okay, and if there is log in this, it is going to give the logarithmic time. Sorry, so O of n, it is used to give the linear time. So this is the correct answer. Next one. Okay, which notation is used to represent the best case time complexity of an algorithm? Okay, best case time complexity means it is the it takes the less time. So I already told you this is for worst case, this is this is for both upper and lower bound, okay, and this omega is used for the best case time complexity. So omega is the correct answer. Fine. Remember, big O, it is used to give the worst case and it is used to give the upper bound. So there is a relation. Upper bound means maximum time. If it is going to take the maximum time, it gives the worst case scenario. Omega, it is going to give the best case and takes the lower bound. Lower means the minimum time. Okay, and theta, both upper and lower bound. So it is going to give the tight bound to you. Next question. If an algorithm has a time complexity of omega of 1, what does it mean? So omega of 1, if it is 1, it is always a constant time. So A is the correct answer. Let's go to next question. Okay, which notation provides the upper bound for the best case time complexity? So upper bound means big of O. So big of O is the correct answer. Next is, if an I repeated the question, I think. Yes. Next question. If an algorithm has a time complexity of n square, what does it mean? So I already told you, n square means quadratic time. So D is the correct answer. Let's go to next question. Which notation is often used to describe the lower bound of algorithm? Lower bound, omega. So omega is the correct answer. Let's go to next question. If an algorithm has a time complexity of big O of log n, what does it mean? So I already told you, if log comes, it means it runs in a logarithmic time. Next one. Which notation is used to represent both upper bound and lower bound of algorithm time complexity? Both upper bound and lower bound or tight bound, it is given by the theta notation. Okay, now let's go to the last topic for today. For today's video, we can say linear data structure. So in linear data structure, we have got stack and queue implementation. Okay, so which of the data structure follows the LIFO principle? We already discussed this. LIFO principle is given by the stack. Okay, next question. In a stack data structure, which operation adds an element to the top of the stack? So if this is a stack, okay, if you have to store 1, 2, 3, 4. So 1, if you insert, it goes here. 2, if you store, it goes there. And this is performed by which operation? It is performed by the operation which is called push operation. So this is the correct answer. Let's go to next question. Which of the following operation is not typically associated with a stack? So we already discussed this question. In queue is the correct answer. In queue data structure, which operation removes an element removes an element from the front of the queue? Okay, so if this is a queue, okay, if this is a queue and if you are going to insert the element, it is known as in queue operation. Okay, and if you are going to remove the element, it is called dequeue operation. Okay, this in queue operation, it always takes place from the rear end. This is called rear end. And the dequeue or deletion operation, it always takes place in the front end. Okay, so which removes the element? So dequeue is the correct answer. Let's go to next question. Which of the following is true about peak operation in the stack or queue? Okay, so peak operation, what it does is, the peak operation, it retrieves the top element in stack or the front element in the queue without removing it. So peak operation, it is not going to remove the element, it is just going to retrieve the element. Okay, so it retrieves the top and front element without removing it. So this is the correct answer. See, top or front. So in case of a stack, from where do we remove the element? From the top. In case of queue, from where do we remove the element? From front. So this is the correct answer, not this. Not from here, not from here. So bottom and rear will not be the answer. Next question. Which data structure is suitable for implementing an undo feature in the text editor? Okay, undo means we are removing, this is used to last in first out behavior. Yes, undo means last in first out. Okay, whatever last task we are doing, we are going to remove that only. That is the undo feature. Yes, so of course it is a LIFO principle. So stack is the correct answer. Let's go to next question. In a stack data structure, which operation removes the top element? Pop is used to remove the element from stack. Which of the following is true about implementation of a stack using an array? So implementing a stack using an array, it requires a fixed size array. Okay, although dynamic feature is there, but it always requires a fixed size array for implementing a stack using the array. So the correct answer is it requires a fixed size array. If you want to implement a stack using an array, the array should be of a fixed size. So this is the one property of stack. Let's go to next question. Which data structure is commonly used to implement the breadth first search? Okay, so breadth first search, remember there are two formula here, BF, depth first search, DFS and BFS. Okay, so breadth first algorithm we always need Q here, and for depth first search we always require the stack here. Okay, so here Q is the correct answer. Later on, while doing the video, I'll cover all this topic in detail. For till now, you just remember DS and BQ, depth first search stack and breadth first search Q. Next question. In Q data structure, which operation adds an element to the rear end of the queue? So adding an element is always forms a queue. Fine. So these are the 40 questions that I solved. Okay, so in next video I'll come up with stack portion. In stack we'll study the properties of a stack, and then infix, postfix, prefix operations, and conversion of prefix to postfix expressions, and then evaluation of postfix expression, and then we'll go to the list portion and then the queue. Okay, so I'll cover all the topic from this chapter in 2 or 3 days. Okay, till then stay safe and thank you.